Hello everyone, welcome back to my YouTube channel. So today I'm going to explain the sine rule and cosine rule. Remember what we studied yesterday had right angled triangles where we used the soccer tower. Now what if these angles are not right angled and they are obtuse or reflex angles? We actually use the sine rule and the cosine rule. Let me try to give you an example here. If we have this being our A, this being our B, and actually this being our C. This A, this will be small a, this B, this will be small b, and this C, this will be small c. So for such an instance, according to sine rule, they tell us sine of A out of small a is equals to sine of B out of small b is equals to sine of C out of small c. That is the sine rule. While the cosine rule will be, in case maybe you want a, it will be a squared equals to b squared plus c squared minus 2bc cos a. So this a cos a. In case it was to be b squared, it would be a squared plus c squared minus 2bc cos of, now this b. You look at the angle that you have, it's what you base on. Are we together? So let me try to give an example here. Assuming we have a triangle, this is our triangle. Here we have B, this is 62, and this is 10. Are we together? And this is 11. And they want us to find this angle here, B. Are we together? So when they want us to find this angle B, we can see the best method to use is actually the sine rule. Are we together? We could say sine A, which is 62 over 10, equals to sine B, which we are looking for, over 11. Are we together? Because it's sine A over A is equal to sine B over B. So we make sine B the subject of the formula. We multiply by 11 on both sides. So here I have sine 62 over 10 equals to sine B over 11 times 11 times 11. So we have 11 sine 62 over 10 equals to sine B. So to remove that B, we actually use, when this sign crosses, it becomes sine inverse of 11 sine 62 over 10. So let me try to show you how they put it in a calculator. You can actually press this is shift, then you look for where there is sine, which will give you sine inverse. You open brackets. Our question here has 11. You put 11 sine 62. Sorry, I'll try to show you. So you put here in brackets, the first one is 11 over, remember it's over 10, over 10, are you together? Sine 62, and then you close the brackets. So, sorry, I put a mistake here. This was supposed to be over 10, but I've put, so our answer is actually 76. So our angle B will be 76 degrees. Then, as we see, so for this instance, if you try to actually use now the other formula, it may not actually work out, because since the let's try and see, and I'll show it to you directly, because it will not work out because we have two angles. It would have worked out in case we did not have the two angles, or in case they were asking us for this distance here. We could actually use the cos rule, but here it's not relevant. But there are instances where you have to use both. Let me try out example number 2. example number 2, it is still the same. Here this is angle 27, here this is angle 123, and here they're asking us now for this, and this is 12. Are we together? So still the best formula here to use is actually the sine rule. You can say sine of 123 over 12 equals to sine of 27 over what we are looking for. Let's limit x. Are we together? So when you cross multiply, you see you have x sine of 123 equals to 12 sine of 27. So x will be equaling 12 sine of 27 divided by sine of 123. When I try to actually calculate it, the sine 27 divided by sine 123 gives us that times 12. Actually, see, our answer is 6.49. So our distance will be 6.49%. So sine normally works when we have two angles that have been actually given, and it would be actually the best formula to use for this instance. Thank you guys. Have a nice day.